everyone. I'm Harpreet Singh, welcoming you to the Future of Work Pioneers podcast. Today, we are speaking with John Roese, the Global Chief Technology Officer of Dell Technologies. John has 20 years of industry experience, including executive leadership of large-scale, complex global R&D organizations. Prior to joining Dell, John held a series of senior leadership positions, including CTO at Nortel Networks, Broadcom Corporation, Enterasys Networks, and Cabletron Systems. John, welcome to the show.
Great to be here.
So let's begin with your background. Tell us about your role at Dell as the CTO, and what do some of the responsibilities look like?
Yeah, sure. Well, hopefully people are familiar with the brand Dell. We've been around for a long time, but they might not realize that Dell about 5 years ago combined with EMC Corporation to create a new entity called Dell Technologies. And today, as of our fiscal last year, we're about $94 billion in revenue. We're probably the largest infrastructure technology company in the world. We cover everything from compute to storage to networking to data protection to virtualization to application delivery platforms, pretty much all things that are infrastructure, meaning they aren't the vertical app, but they're anything that powers it in the cloud environment or the telecom environment or the edge environment is probably inside of Dell. Now, my role, I'm the Global Chief Technology Officer. Primarily, I'm responsible for a couple of things. The first, obviously, is the overarching technology strategy. How do we make sure that we're orienting this giant company towards the future of technology? And we'll talk about that throughout the conversation, I'm sure. The second major area that I'm focused on is making sure that we don't drive off a cliff because we missed a technology inflection. And it's kind of a joke, but basically a company like Dell or any large technology company is constantly having to evaluate and understand what is emerging because technology is fluid. And so I own most of the advanced development and research functions, which basically allow us to cast a very, very wide net so that we look at everything from the future of semiconductors to the future of cloud stacks, to the future of development tools, to the future of developer experience, to the data pipelines. And so, but all that boils down to one thing, which is my job is to make sure that the company called Dell Technologies does not miss technology inflections and is able to properly see them early enough to navigate, to either exploit them, avoid them, manage through them, or in other ways, end up on the winning side. So, it's an interesting job. We have 160 something thousand people downstream that are depending on me and my team to make sure that we don't run into those obstacles.
Looks like an exciting role. So Dell Technologies is in the business of digital transformation. When you look at the emerging technology landscape more broadly, which technologies are the most important when it comes to affecting digital transformation?
Yeah, in fact, about 2 years ago, one of the things I helped develop was we asked that question. We have been talking digital transformation for probably going on 5 years, 6 years now. It's this concept of there are digital businesses and there are people that aren't digital businesses. And it turns out the digital businesses in any industry tend to win. They just get better insights, better decision-making, better optimization. When you're data-driven and digital, you tend to outpace people who are not using technology. It sounds pretty simple. But about 2 years ago, we had been fairly far along on this digital transformation journey. Most customers are in some stage of digital transformation. Very few have declared that they've completed it, because I'm not sure you ever do. But the vast majority of enterprises have at least started. But then we started to think about, well, as a concept, digital transformation is just using technology to win in your space. But then the question is, well, what technology? At that point, we knew that you were going to use, clouds and you were going to use IT technology, and the general sense was true. So we tried to predict what the future would look like and what would be the most important technologies. Now, there are many technologies, but the most important ones in the near term we actually settled on were 6 major technology areas that we felt not only were important to the future of digital transformation in the near term, but they're also important for Dell, and they became bedrocks of our forward-looking strategy. In no particular order, that they are the evolution of the cloud ecosystem. We've gone from not having clouds to thinking public clouds were the answer, to thinking, that maybe we ought to actually use more than one cloud, to then realizing that those multiple clouds should come together in a multi-cloud system. And that's kind of where we are today. And that's going to continue to evolve into more as a service offerings, more automation. But cloud will continue to be a critical area as an operating model and a technology area that it by no means is done. There's a lot of work in front of us. Number 2 on the list was we saw that the cloud ecosystems, private and public, were actually starting to be distributed. And so this thing called Edge showed up. And Edge basically said, well, if you actually find that the data and the processing of the data actually needs to happen in the real world, doing all of that work in a data center that isn't the real world is probably a bad idea. So we had to think about what would be the way to distribute the data pipelines and the application pipelines out into the real world. That became Edge, which is a very important technology for people to understand. Number 3 on the list was a very specific technology around 5G. And this basically, we said, we're not in a world where people are in one place, and we're not in a world where devices are in data centers. They're distributed all over the world. And while we know how to deal with the data and the applications, did we actually understand the networking characteristic? And we can talk a lot about 5G, but the bottom line is we characterized it as a critical technology because it creates the first kind of interconnect built in the cloud era. And it's got a lot of work to be done, and there's a lot of risk associated with it. But if we get it right and have a mobile broadband environment that's high enough speed, low enough latency, has advanced services to deal with things and people, and low latency and high density, we might actually have a really strong connectivity fabric for this distributed multi-cloud. Number 4 on the list was AI and ML. And we can, again, spend hours on this one. But basically what we realized was that AI and ML wasn't just about algorithms or programming or even silicon. It was about a redefinition of who was going to do the work between people and machines. Up until recently, we kind of said all mechanical tasks were a good thing to have a machine do. And even digital mechanical tasks like payroll made sense to do in a piece of software. But we kept all the thinking and decision-making tasks in the hands of people. Give you a nice dashboard and then a person will make the decision. AI/ML has gotten to a stage now where we have significant technology capabilities so that we can actually start to divide up the thinking and decision-making tasks. And that's a huge shift for people. And the other dimension that we discovered is not only was that interesting, but it was actually starting to accelerate to a point where our prediction is within about 4 years, the majority of capacity of infrastructure in the world will be delivered in the service of AI and ML. So it'll become the dominant user. So that makes it a very important technology. Number 5 on the list is data management. And this was not about building a better database. We have plenty of databases. We're really good at data at rest. We're not good at data in motion. When data moves from a sensor through an edge across a cloud into an infrastructure that ultimately an AI processes and then it tells the sensor and the actuator to do something different, that is a very complex problem to solve. And the state of the industry for that is probably 5 years behind the state of the art in application delivery and application deployment across clouds. So we really focused on this area of data in motion and saying we have to solve for that both at Dell, but in the industry in general, because more and more of the data that we process won't be put at rest, thought about, and dealt with later. It will be immediate. Within 100 milliseconds, we may have to make a decision on it. And there's a whole new tool chain and systems around that. And then number 6 on the list was security, where we have a pretty maybe politically incorrect point of view, which basically says the security industry is broken. The fact that we literally live in a world where people believe that there are APTs or advanced persistent threats inside of their environment already right now, and they just live with it because we've gotten so far behind being able to react to the security threats that are out there, says we've got to start thinking about this differently. And honestly, while we don't have all the right answers, we do know that we have to reverse this trend of just fragmentation of the security community. It needs to become a more natural, integrated, intrinsic part of the infrastructure. It needs to be built into kind of every dimension of how we think about infrastructure, not just the technology, but the supply chain, the vendor relationships, the business models. And we really just haven't achieved that yet. So for us, it's an incredibly important area, tons of work, probably the hardest one to solve for. But again, your question was, what are the 6 big technologies that we think matter? Those are the 6. And if we get them right or make progress, they'll move the industry forward.
So just taking some of these, kind of digging deeper into them in the context of security, that's such an important problem. So how does an enterprise kind of start thinking about this? Is it, do you start with like a SOC 2 kind of a process, or, what do you do? How do you tackle it?
Yeah, there isn't a single answer. This is one of the challenges with security, and we've been spending a great deal of time. In fact, one of my jobs this year is to kind of get our next generation security strategy sorted out. And quick answer, we don't have one yet. We're working on it. But the current generation of thinking actually opens up some opportunities for customers to maybe do some things in a different way. The first, obviously, is, to your point, have a process, have a framework. But what we realize is the framework for securing your environment probably isn't a bottom-up framework. It's actually more likely to be an industry-specific top-down. If you look into industries like financial services, where it's very much a risk management model, or you look into industrial, which is very much a supply chain model, those are all good. Because in your industry, if you ask the question of what you're trying to protect, the answer is different depending on what industry you're in. And so the first thing we're kind of advocating is for people to be aware of the industry efforts to kind of define risk and what the threat models are for your industry, and to not assume that they necessarily cross between industries. Sometimes they do, but in general, it's a very personalized thing. You're trying to protect a manufacturing environment. Therefore, you should understand manufacturing and its specific threats, opportunities, and constraints. That is different than protecting a bank. So that's the starting point. The second piece, though, is once you understand what you're trying to protect and what good is based on your environment, you start thinking about how to make good happen. And here we run into a couple of issues. The first, obviously, is you are trying to protect something that people are trying to attack. And if you flip around and ask, what are people attacking these days? They are no longer attacking a specific vulnerability or a specific product or even a specific thing. They are attacking your entire end-to-end process. SolarWinds showed us that was an attack on the development process and the distribution of that developed code into the SaaS environment. That is a far more sophisticated and advanced target than they're trying to hack your router. And even if they're still trying to hack your router, the starting point has to be, well, what are people trying to attack? Are they attacking a point in your environment and only caring about that? Or is that a means to an end to attack your entire end-to-end process? The minute you understand that, you start to ask the question of, well, what is that end-to-end process built on? And it turns out that it's not built on a single product. It's built on a system architecture. And in this case, your multi-cloud system, which might include public cloud, your private environment, and your edge environments, and your client devices, and the software and data pipelines on them, is actually the technology basis you have to protect or develop your security strategy around. Developing a strategy around any one point in that would be insufficient. So that gets us to the last piece of the puzzle, which is, if you understand what they're trying to attack, if you understand what their goal is, if you understand what your infrastructure looks like that they're attacking, then it becomes a question of, well, what is the security ecosystem that you need to form, need to look like to actually introduce any kind of countermeasure or security architecture? And this is where we're pretty vocal about, you really need to be building your security strategy based on the ecosystem of suppliers and technology providers that actually are tied to the actual thing you're protecting, which is the end-to-end system. And that starts to limit the options, because you really have to work with big players like Dell, or even to some extent the cloud providers or big systems integrators, where if you focus on just the point products, a firewall is a fine piece of technology, but it doesn't protect the end-to-end environment, doesn't even understand it. And so it becomes a world where systems integration and system architecture as a way to not just define the risk, but also to define the answer. And that has to extend into supply chain understanding, your vendor ecosystem, business models, all things related to the system are now important when we start thinking about security. And now that is a very hard transition for most people, because most people have kind of dumped their security to their security team that then buys security products to patch holes and fill gaps, as opposed to saying this has to be intrinsically built into the end-to-end architecture, not just from a technical perspective, but from a vendor and a relationship and ecosystem perspective, and an understanding what the target is. So there's a big shift coming to kind of up-level the security discussion. Sometimes people call that shifting from security to trust. I think that's semantics, but it's fairly accurate, because you can't trust the world if you don't have an understanding of the foundational capabilities. But in this case, I think the big shift for us on security is likely to be this change of acknowledging the attackers are not attacking a product or a feature. They are attacking your end-to-end business. And that means that you have to build an ecosystem and a technology basis and a platform that is actually designed to protect your business. Well, it turns out you already have one of those, and that's the multi-cloud ecosystem that you're already building to run your complete business. So if you're running it on that system, you might as well protect it inside of it, which is really this intrinsic security story.
So there's a lot of misconception about 5G being just faster 4G. So what do you say to people who have that kind of a perspective? And what are some of the use cases that you're most excited about?
Yeah, no. In fact, it's reasonable for people to have that kind of disappointed reaction this year, and that's because the first versions of 5G that have got become available are really what is known as non-standalone 5G, which basically is 4G with a little bit of 5G attached to it. And the result of that was that all you got was maybe slightly faster mobile broadband. You got to, and by the way, mobile broadband's a big deal. If you remember, if you were alive and in the IT industry in the 3G world, 3G to 4G was revolutionary because we actually put broadband over the air for the first time. And that's good, but just having a pipe is not necessarily compelling anymore because we kind of expect that as table stakes. So the thing to remember is, look, last year and maybe even this year might be a little disappointing. You'll get a little better coverage, a little better performance, but don't let that dissuade you from being excited about 5G. The real 5G, release 16, release 17 of the 3GPP standards, built on a standalone 5G environment. There's really a cloud and software-defined system. Is fascinating and exciting, and it's incredibly powerful. Let me give you 4 examples of things that it can do that you can't do in the, let's call it the 4G world. The first is what's called enhanced mobile broadband. That's kind of what you're seeing now, but we have not fully exploited the high frequency bands and the higher channel widths. There was just a bunch of auctions in the C-band and CBRS areas. You're going to start getting the ability to not just have a pipe, but to have a much bigger pipe, a pipe that is in gigabit speeds potentially and with much lower latency. And even though that isn't revolutionary, if you suddenly, you're used to having 40 megabits per second, and I don't know, a year from now, you can get 200 or 300 meg. We saw what happened in home broadband. It opened up video, high definition, all kinds of things you really can't do over the air yet will happen. But that's the most minor one. The other 3 are in no particular order. One's called ultra reliable low latency communication, which is this idea of in this system being able to optimize the radio access to be able to provide potentially as low as maybe 1 millisecond round trip latency over the air. Now, if you're watching YouTube, that does not matter to you. It's not a consumer thing. It's very much an enterprise thing, because if you're a sensor in a factory that's controlling an actuator that's doing machine process control, you may have to reduce the round trip latency to make process decisions to 5 milliseconds. You simply can't do that effectively over Wi-Fi or 4G. You can in a 5G environment. If you're a drone providing real-time telemetry of an environment, and it's incredibly important that this actually be incredibly smooth and effective, and it also must always survive, even if there's disruption in the environment. Ultra reliable, low latency communication isn't just about latency, it's about the reliability of the system. And so now you have this idea of different kinds of performance, lower latency, higher reliability showing up on the same infrastructure. The third is something called massive machine type communication, which says, LTE and 4G was built for people connecting on smartphones. It was really built for video on smartphones. 5G is about connecting everything. And so one of the characteristics is the ability to manage efficiently over 1 million sensors in a square kilometer. Now that's a very powerful tool, because it's not just connecting them, it's managing them. It's taking into account that they want to actually keep their battery life active. They want to be able to last a long time. So it's a very tuned environment to know, not only do I have sensors, but I know how to build a network that's designed for them. And then lastly, number 4 on the list is a thing called mobile edge compute, which is this idea of pushing some of the compute layer out into an edge that's actually effectively in the radio access network. So not only are you getting 5 millisecond round trip latency, but the other end of it is compute within that 5 millisecond boundary, which is very, very powerful to push real-time processing and other services. Now, the one thing you'll recognize from everything I just talked about, if you're used to the consumer side of cellular, is pretty much everything I talked about is irrelevant to you, which brings us to the biggest and most exciting thing about 5G that most people won't see directly, is that it was really built for enterprise use cases. It was built to revolutionize our transportation sector, our industrial sector, our healthcare sector, not by just faster YouTube, but by connecting everything, by giving it differential services, by bringing the compute environment into it. So this is a very, very sophisticated and important platform underneath this cloud ecosystem that's been forming for the last 10 years.
This episode is brought to you by Xperfy. Incubated in Harvard Innovation Lab, Xperfy provides custom future of work solutions, such as private talent clouds and skill taxonomies. Xperfy differentiates itself by using subject matter experts to pre-vet and pipeline candidates for AI and high-end technology skills. However, Xperfy Talent Cloud Platform is skill agnostic and can be licensed to build custom talent clouds for any and all skills. In a different use case, enterprises interested in employee intermobility can license the Xperfy platform to create an internal gigs marketplace where interested employees can be algorithmically matched to projects, gamifying their learning experience. Visit www.xperfy.com for more information.
You've talked about the importance of how 5G is coming back to the U.S. in terms of the telecom sector seeing a revitalization. So for the folks who are trying to listen, who are listening and thinking about careers, what kind of career advice could you give them? What could they focus on for where you see the jobs being created? In other words.
Yeah, no, this is one of our biggest risks. You mentioned the telecom industry coming back. I'm one of the people that was here before, but I was the CTO of Nortel in 2006. Nortel doesn't exist anymore. Lucent doesn't exist anymore. Motorola is a very different company. There's no telecom companies in the wireless world based in the US that are US companies. But what's happened since we started to move into the 5G era with specifically technologies like Open RAN and kind of new approaches of kind of using cloud and software defined and open architectures, it has created an interest by companies like Dell and Microsoft and even industrial companies like Corning. And, clearly there's a lot of startups emerging where there's now an interest level of how do we build the next ecosystem to deliver on this modern take of wireless, which is, 5G standalone and definitely 6G are going to look a heck of a lot more like the cloud and IT ecosystem than they do like the telecom ecosystem, even though telecom will still be important. Because of that, what's happening is most of the big US technology companies, including the big cloud companies, the big infrastructure companies, we are all looking at this and saying, boy, our technology is already being pulled into how you build 5G today. Why don't we get a little bit more engaged on it? But one of our biggest challenges is that for the last decade, largely telecom skill sets weren't that important other than from the consumer side, meaning working at an operator. Building this stuff was mostly the functions of the Chinese or the Swedish or the Finnish or somebody else, but not us. And now that that's changed, it is incredibly important that two things happen from a skill set perspective. And I'll make a shameless plug. If you came from the telecom world, if you understand radio resource, if you understand telecom, but haven't been doing it for a while because you got busy doing something else, look at this industry because there is a significant need for us to rebuild it. And that means we want to pull that institutional knowledge back together. I'm doing it with people that worked for me 10 years ago, 15 years ago. We're starting to pull them into companies like Dell. The second, though, is this is going to be the foundation of modern IT and data and digital business. The idea that you could have a global manufacturer that doesn't have incredible dependencies on modern mobility technology just makes no sense. And so maybe you don't want to build the telecom system itself, but you want to build apps for the modern banking system or the modern industrial system, this is incredibly important that you understand the capability set that lives in this modern environment. So becoming very literate about these new technologies. What is standalone 5G? What are those acronyms that John just rattled off about different characteristics? How as a developer can take advantage of them to distribute my code in a different way, to run my data pipeline in a different way, to connect to things in a different way. It's incredibly powerful tool. It's kind of like the era where, software used to be built in constrained systems that were a black box, like a mainframe or a mini computer, and then the internet happened. And it wasn't just the people building the internet that mattered. It was the developers that understood the internet had happened and started to build their software differently. Well, 5G and 6G are likely to be that disruptive. So two big things. One, if you have telecom skills that you didn't think were valuable because we kind of lost our telecom edge in the US, that's coming back. And there are lots of jobs there. Number two, if you're a developer, learning about this new capability and being a developer who can intelligently utilize a more distributed mobile environment based on things like 5G will give you a significant advantage in your toolkit to basically get to a better outcome. So I think it's going to be a very important catalyst of skill sets, direct demand, but also indirect demand on our developer and technical communities.
So John, if you had to develop a learning track for these folks who left the industry 10 years ago, want to come back, what would those courses look like? What would they be learning today to do that?
Yeah. The challenge is, we're actually kind of light even on the knowledge transfer, because these technologies were, what happened to the industry over the last 10 years, it compressed down to be a very small number of players, and they didn't really have a need to educate a lot of people. So now what we're seeing is, specifically because of the advent of open source, of open ecosystems, there's a lot of information out there that used to be kind of a black box. You don't have to go read the 3GPP, release 16 standard. You can. That would be a very good thing to do if you're highly technical and bored. But what you can do is you can go participate and get engaged in the Open RAN community. That's an open source initiative. It's designed to be an open community. It's like getting into the Kafka community or any of the open source data management tools. It's got a much different composition of players. It's not just telecom people. So my first advice is, look, there's probably not a lot of good books on building modern telecom as we forecast. Old telecom, yes, new telecom still forming. But like everything, sometimes you can learn more by just being attached to the communities that are surrounding you. In this case, the Open RAN community, some of the ADAS in the US has a whole set of things thinking about 5G and 6G and how these are deployed. That would probably be the best place to look. Beyond that, look at the vendor community. What I will tell you is, companies like Dell, Microsoft, Google, Amazon, Microsoft are all absolutely engaged in this ecosystem. And you probably, as a developer, already have connective tissue to us. You're probably already working with us in some area. You might want to just ask, what is what's going on in the 5G space? If you asked me at Dell, I would connect you to our 5G ecosystem and try to pull you into that environment. So unfortunately, because there is no big book and there aren't a lot of online courseware that's really ready yet, even though that's a great area to develop it if you're in that business, because we're going to have a lot of demand. The near term is get involved in the open source communities, get involved in the developer communities. There's a lot of that going on, because to revolutionize telecom, we actually need to pull the cloud, the IT, and the telecom industries together. And one great vehicle to do that is open source and open communities, which generally tended to work really well for the last 5 years of technology.
So we often hear about China accelerating the pace when it comes to 5G and other technologies. Even the AI investments, right? We see they're making more AI investments than the military in the US. So how do we, think about that from a geopolitical perspective? What can you tell us about what's happening in this different continent?
Yeah, no, I mean, we should be very aware. I mean, I have the, I guess, interesting distinction of before I joined EMC and after I left Nortel, I worked for a small Chinese company called Huawei. This is before all the geopolitical stuff, but I built and ran their advanced technology organization, a company called FutureWay. That was a decade plus ago, and the world's changed a bit, but I got a good firsthand view of what does a modern Chinese technology company look like? And what is the Chinese government doing to catalyze that industry? And what I will tell you is they're very serious about it. They've realized that technology is a great equalizer. It can be a strategic advantage. And so the big areas, obviously, were telecom, where Huawei emerged and ZTE emerged, and they've done quite well. They have realized that AI and ML are foundational. And the amount of courses that are producing engineers and data scientists, data engineers is significant. They have entire regions that are characterized as AI cities or test beds or development zones. And they've gotten really a lot of energy behind that. They have some advantages over the West in the sense that one of the things that makes AI systems interesting is the access to data. And the rules of data access in China are a little easier than the rules of data access in the US, and definitely easier than the rules of data access in Europe. Now, that's neither good nor bad. It just is what it is. But it does mean that they may actually have some advantages in how quickly they can develop trained models and get access to large quantities of data. And that correlates in many cases to improvements in AI outcomes based on algorithms. So we should assume that China is very serious. They understand this. And they're going to make it a strategic priority long-term, and it's going to be a competitive battlefront. Now, that doesn't mean we aren't well-positioned. In fact, today, the modern semiconductor ecosystem to support AI is heavily dominated by the US and the West. The AI algorithms, we by no means are behind. There are lots of great people in the US and Europe that are developing fantastic AI algorithms. Our data ecosystems are a little more constrained, but we're inventing. For instance, if you're familiar with concepts like transfer learning, which allow you to take a trained model and basically use most of it to do an entirely different problem that can benefit from some of the layers of the model that you already have trained. it reduces the amount of data that you need dramatically by being able to leverage what you already have. And then obviously there have been very large projects that have shown how we can gather enormous quantities of data and get very interesting trained models to do things like voice recognition and to talk to us. The bottom line is we should just view this as, from a geopolitical perspective, a strategic area of technology interest, not just for the US or for Europe, but also for China and for India and for any developed country that understands that this relationship between people and machines is contingent on your ability to make the machines work better. And the technology used to do that is machine learning, artificial intelligence, and the access to data to ultimately get to better outcomes. One interesting thing that is starting to happen, though, which is fascinating, is that, we used to think of it as we have AI engines, AI algorithms, AI systems, and then we have data. And if you have the data and you can put it into the engine, you can get a better answer. And that still is true, except there's now an intermediary stage. And that is that data that you create, in fact, gets turned into something before you use it. It gets turned into a model. And trained models are now becoming probably more important than the raw data. You have lots of raw data, but once you get a good trained model that understands how to do voice recognition or image recognition, it can continue to learn based on the data it's processing as it inferences. And so one of the things I've been very big advocate of is that people who are developing an AI strategy shouldn't just think about the raw data, and they shouldn't just think about the actual pipeline and processes and algorithms. They should start asking the question of what kind of models are they actually creating, and are those models actually a strategic asset in and of themselves? I actually think they are. If you look at an autonomous vehicle, it's the model that it's using that actually makes it valuable, not the raw data from the road or the system it's running on. Those things will change, but the model, once you get it right and it starts to work, that's the core of an AI system, even if it's a very rudimentary model for machine learning or a very specific advanced model in a deep neural network. And so this is an area that, honestly, we are all going to live with. In fact, as I mentioned, Dell's 6 priorities, this is the only one that we're not really building a business around, because it's in all of our businesses. It's everywhere. It actually touches our business processes, our core products, the platforms we build. And I think people have to start to understand that AI is that important. It is a foundational, pervasive technology. It's complex, it's significant. And to your point, we should in no way underestimate the rest of the world's capability to innovate in this space, because it's like oxygen. It's necessary for technology to move forward.
So staying with this topic of AI, ML, you've pointed out in the past that AI algorithms are not merely a technology, but also the biggest consumer of an enterprise's technology infrastructure. So unpack this idea for us, and how do companies prepare for this new future?
Yeah, I think this is a statement I made a while back, because I was starting to think about, how do you think about AI? Sure, it's algorithms and semiconductors and data and models and all the things we just talked about. But then I started to ask the question of, when you build infrastructure, you're not building it arbitrarily. You're building it for something. And sometimes we think it's to run code, or we think it's to process data, but those are generic terms. The reality is you're building it for users. There are users of your infrastructure. If you had no users, you don't need an infrastructure. If you have users that initially are people running spreadsheets or office productivity or email, those are classes of users. And then we realized in the IoT world that we have machines that connect and they process and ask for data. And it turns out that when you actually look at an AI, whether it's even a basic machine learning algorithm or a really advanced deep neural network, it has actually more similarity to a user than just an infrastructure technology. It has very specific expectations of the infrastructure. It has amount of data that it's going to need. It needs access to certain services. It requires certain types of compute. It requires certain security privileges. It requires connectivity. It's a user. And so a number of years ago, I said, you got to stop thinking about AI as technology. You got to start thinking about it as the newest class of user on your infrastructure. It was people, then it was machines, and now it's also AIs. But then we did the math and we asked the question of, well, if now AI is a user, well, how much of the infrastructure are they going to use? And about 5 years ago, there's some really good, or last year, there were some good studies that predicted 5 years into the future that if you looked at the math, the amount of compute capacity and data production in any modern infrastructure would be dominated by serving the needs of machine intelligences. It would become the dominant class user. It doesn't mean it would be the dominant number of users. It would just mean in terms of MIPS and bits and IOPS, your AI and your machine learning algorithms would use more than anyone else, everybody else combined, more than 50%. And that led us to a conclusion that said, well, if the user changes and the dominant user changes from people to this new class of machine intelligence, and it is consuming from an infrastructure, and that infrastructure was largely built to serve the old type of user, maybe we ought to change the infrastructure to be more optimized for the new kind of user. And that's when Dell started doing things like building, we have, what we call extreme accelerator servers, these very dense acceleration servers that they might be 2 sockets of x86, and they might support 20 accelerators or 10 accelerators. And the idea is that, you don't need that to run email or SAP, but you do need that to efficiently run at scale machine intelligence. We then started to look at the storage ecosystem. It turns out that, if you can't feed the AI system fast enough, it doesn't work well. And so we did some weird things like, a number of years ago, we announced one of our scale out file system products, Isilon. We came out with an all flash version. Now, typically scale out filers weren't really a high IOP system. They weren't really even a high throughput system in most cases. They were just big data. Well, you make an all flash version and you can move an enormous quantity of data out of that system and into that system. And when we first announced it, people were like, well, I don't need that to run my databases. I don't need that to support my, image files for my virtual machines. We said, yeah, you're right. But you do need it to feed this accelerated compute framework that you're going to need to run your AIs. And even on the networking side, we discovered that, for instance, when a deep neural network starts to shuffle the data, it readily overwhelms 10 gigabit interfaces on LAN ports because there's just so much data moving around that it can actually blow up the network. And so that led us to 25 gig and 40 gig and higher capacity. And so the conclusion was not only is AI and machine intelligence materializing as a new class of user, it's likely to be the dominant user. And if it's the dominant user, then over the next several years, you got to kind of shift your design center away from building for running email and office productivity and databases to really running these AI algorithms really well. Higher performance storage, more diverse acceleration, heterogeneous compute, different networking topologies, different exposure at the virtualization layer, different ways to abstract it. Because if you get that right, you can always retrofit it to support email and databases. Those will run on anything, but the AI systems need to run on something fairly special. So we do see a big shift in infrastructure design over the next 3 years because of the emergence of AI as not just an interesting science project, but actually the majority of capacity demand on infrastructure.
And also from a cost perspective, right? When we're looking at GPUs, those servers are going to be the most expensive.
You bet. It brings up a great point because the accelerator world is fairly nascent right now. We have x86s, which are very good. Many AI algorithms run just fine on modern Intel processors or ARM processors, but a lot of them, especially very advanced and high performance training and inference, require more, or they do better on optimized architectures. Problem is the optimized architectures in the middle tended to be early GPUs and FPGAs, which really weren't optimized. Now the GPU world has started to become very specialized for AI. And now there's a whole new class of AI semiconductors, the neuromorphic processors, the parallel processors, the TPUs, the graph cores, there's lots of them out there. And the game that they're all playing is, for this particular class of algorithm or class of AI, what's my MIPS per watt? That's the metric. And we got to get better at that, because if we can drive the MIPS per watt to a better ratio, it has the result is it drives cost down. And if your capacity is going up, but your cost remains fixed on a per unit of currency, you're gonna run out of money. So you have to drive the cost per bit down dramatically, across MIPS per watt down. And the only way to do that today is not Moore's law anymore. It's not Dennard scaling. Those things are not really working out as well. It's moving to these heterogeneous, diverse computer architectures, what's called domain-specific architectures. And that's a very useful tool. It doesn't render the traditional microprocessor irrelevant. It just augments it. But that's all the game of, look, if your biggest user emerging is also your most demanding user, and it's going to require more capacity, not only do you have to rethink your architecture from a technical perspective, but you got to make sure that the economics don't break, that you can keep driving the cost down on MIPS per watt and other services, which, is something that the industry has been fairly good at doing, but now we have to have new tools to do it.
Let's talk about multi-clouds. Tell us, especially the listeners who are not familiar with the concept, what that is, and what an enterprise strategy should look like.
Yeah. The cloud era has been interesting. I mean, I've been involved in it since the beginning, since people started using that word a long time ago, which goes back well over 10 years, in terms of it being in the modern vernacular. And it's gone through a little journey. When cloud first materialized, it was a term used to describe a managed public data center. It was basically an IaaS, and this is early Amazon or Azure, or there were other clouds that were out there that don't even exist anymore. And the idea was that maybe you could not own your infrastructure and you could actually just consume it as a service. And that's what we describe as the cloud operating model. The cloud operating model started a long time ago, and it just says, what if you didn't own your infrastructure? You just consumed from it. You paid as you used it. And that's actually a very appealing proposition. But in the early days, it was described and it delivered as a monolithic data center run by somebody else, presented as a service. Great, that's a public cloud. Unfortunately, back then, it created this perception that was cloud. Cloud was this physical thing, like an Amazon data center or a Google data center, and that isn't true. But for about 5 years, the world started to think that was the answer. In fact, there was this vision in people's mind of the destination. When we're all done, there will be one logical data center out in the ether that everybody will consume from, and we'll never have to think about IT again. Now, that didn't work out so well. The reason it didn't work out is that we started to realize that there were actually multiple public clouds that existed. So, what you got from Amazon was different than what you got from Google. And that's good. It's called competition. It's called diversity. But at the same time, we realized that cloud operating model could also be deployed in on-prem infrastructure. Your existing infrastructure could be cloudified. You could interact with a VMware substrate as a service. And then we started to realize that telecom clouds could exist and edge clouds could exist. There were many places where you could apply the cloud operating model. That got us to what I would describe as the multiple cloud era, where suddenly this operating model of easy access to kind of an as a service was dominant, but it was dominant everywhere. And there were all these pockets of cloud, many public clouds, telco clouds, private clouds, edge clouds. The problem with that model, when we got to the multiple cloud era, which is largely where most customers are today, was it turns out that none of those clouds by themselves is a significantly sufficient infrastructure for a modern enterprise. There are almost no examples where you can run your entire enterprise in any one of those. Public, private, edge, makes no difference. And so we started to realize that, you actually needed a collection of clouds working on your behest. By the way, this concept is not new. You would not dream of building your modern internet infrastructure on a single homogeneous provider. You want multiple infrastructure providers for diversity, for cost reasons, for lots of reasons. So it's totally logical to actually want multiple cloud providers, both public, private, edge, telco, to all be available to you so you can do cost triage, but more importantly, you can get access to their collective capability. You might get better, upstream analytics from Google. You might be able to get better high performance processing at the edge. You might get better privacy and controls in a private cloud area. And so over the last probably 3 or 4 years, people started to realize, inevitably, whether I like it or not, I'm going to end up using multiple cloud environments together. And that led us to this era of multi-cloud, which basically said, well, if that's true, how do you create an environment in which those multiple clouds actually start to behave like a system, that they're not completely incompatible, that data and code and people and users can move across them? And so that really began the last 3 years, where definitely Dell and VMware and a lot of other people have started to turn certain elements of the architecture horizontal to say, while you can have silos of cloud infrastructure, there are certain things that have to cross those boundaries. And in no particular order, they include things like networking. So software-defined networking is incredibly important because you want to be able to provide logical connectivity between what you have at Amazon, what you have in Google, and what you have on-prem, what you have at your edge. And SDNs and SD-WANs tend to be really good tools to do that if they're applied in a multi-cloud context. The second level is application deployment. When you push code into production, you want your developer to push it into the right cloud. And it turns out that was hard to do in the past, but with things like Kubernetes and some of the upper layer cloud native mechanisms, you actually have tools where you can build a containerized chunk of code, you can put it in a repository, and then you can push it into production in any of these clouds based on where it needs to be. That's a very powerful tool to turn horizontal. The third is health management, which is the idea you need to be able to see the multi-cloud. And there's lots of tools that like Cloud Health and others that can do that. And the fourth is this concept of telemetry, which really is, can you understand all of the information coming from all these clouds and create a common kind of data layer to understand them? On top of that, we are now entering an era where data pipelines are being built in this multi-cloud concept. We actually find many examples where it's a private edge environment that's actually gathering the data. It's then pushing it into a cloud environment to aggregate it. And to maybe run some of the analytics, but it's then pushing it upstream into a public cloud environment to do something like large scale AI training or to interface with other systems. It's totally normal for your data pipeline to cross these boundaries. And so a lot of the tools are now getting up leveled to be more logical and to be able to express a data pipeline across a multi-cloud environment. And then lastly, from a security perspective that we talked about earlier, if the multi-cloud infrastructure is inevitably your foundation, we're seeing the security industry start to shift to say, well, I really have to think about multi-cloud security, which is really how do I do security and trust across this collection of clouds and organize their behavior to get me to a positive outcome. So multi-cloud is just a natural progression of starting from mono clouds to multiple clouds to now a multi-cloud system. And I like to include that system word so people understand it's not sufficient just to have a collection of clouds. You have to have the necessary horizontal technologies to allow code and data and people and users and telemetry and security to understand that they're on a multi-cloud and can take advantage of it. And we're not quite there yet. We have lots of really good first generations of that, but I think most of our work for probably the next 5 years will be about refining and maturing this idea of the hybrid multi-cloud system, which is really the end state for most customers. That's what you want. And if you get to that point that you can look down on it as an enterprise and see a coherent view of a collection of clouds at edges, at telco, at private, at public, all working and providing services to you, then you have a foundation to actually have a digital transformation on.
In the beginning, you mentioned edge computing as a strategic imperative, one of the 6 technologies you thought are going to be important. Help our listeners understand what edge is and what are some of the use cases.
Yeah, edge is interesting because remember back when the cloud ecosystem started to form, one of the consequences, because most things that we ran weren't real time, they weren't IoT, they weren't data oriented, they were email and databases. There was a pretty significant shift of, can I just push all of that stuff to centralization? Can I stop having an email server under my desk or a database out in my factory? Let's just centralize everything. And so for about 10 years, we really were centralizing IT. We were getting all IT out of the real world because we weren't doing real-time things. Email does not need to be in your factory. And so that resulted in, very concentrated centralization of code and applications. But then we discovered something, and that was that as we entered the data era, almost no data is created in a data center. Data is created by people and things and entities out in the real world. And in fact, the actions of data are almost always out in the real world. When you actually get into the world of data-driven, digitally transformed businesses, you're not transforming something arbitrary. You're transforming healthcare and manufacturing and transportation. And so as soon as we realized that we had to reconstitute IT out in the real world, because if all the data was out there and all the action was out there, and in fact, today we predict over 80% of the world's data long-term will be created outside of data centers, it was important to have the right kind of IT to make that happen efficiently. And that's where edge came in. Edge was not arbitrary. Edge was, how do you extend the multi-cloud out into the real world to get an optimization for the fact that your data and users are not in your data center, that they need something to complement them to make them work better. Now, it turns out that that's an abstract concept, but to really make the decision about what belongs there, you have to have some rules. And so we've actually looked at this for a long time and come up with a set of criteria to tell you what belongs at the edge. And it turns out there's just a small list. The first is, does your application or workload need real-time processing? Meaning, if you have a workload that isn't real-time, it can run anywhere, it doesn't need to operate in 30 milliseconds, then run it in a private data center or public cloud, that's fine. But if, on the other hand, that control system needs 5 millisecond response time and it's 30 milliseconds to get to your data center and back, you need to put it somewhere else. Edges are a great place to do that. So real-time processing tends to be a good use for edge. Number 2, the data pipelines that are forming, meaning moving data from beginning to end, tend to be so big that they overwhelm the internet. If we tried to take all the sensor data of the world and backhaul it back into the public clouds of the world, we would run out of capacity. There's just more data being created. So the second thing you do at the edge is data reduction and data management. And we already have examples of this. On the outbound side, things like CDNs, content delivery networks, have been doing this for ages. They make it much more efficient to deliver content across the internet by pushing a bunch of the content out to the edge. But now we have the ingress happening where if you're doing something like video image processing or facial recognition, sometimes you want to do that entire task at the edge because it's real time. But in other cases, you want to actually do data processing at the edge. Like we do a thing called contextual compression, which says, if I know that the AI back in the data center is looking for faces, I can look at every image and use machine learning to kind of de-res everything that isn't possibly a face. And I can compress the image dramatically, but keep full resolution anywhere where the AI is going to be looking. And that results in a really powerful reduction of data flows across the internet. That's an edge use case. Number 3 on the list is the IT-OT boundary. Many things at the edge don't speak internet. They speak Zigbee and Modbus and ModTCP and these very old and localized interfaces. Edges are the translation layer between those legacy and local interfaces and the internet, so that needs to be at the edge. Number 4 on the list, though, is security. When we think about the security ecosystem, one of the problems we have is that, when we try to secure sensors and actuators, we run into a problem. Those things are intrinsically simple. We need to reduce their cost to 0 and basically reduce their demands to almost 0. Otherwise, they won't be able to be deployed. When you do that, they don't have a platform to run sophisticated security technology on them, yet they're a target. So there's a concept, Gartner uses it, called SASE, and there's many different approaches, but it basically says, what if you put the security functions to protect the things at the edge in the edge? That literally one hop away was a security capability on an edge node that was designed to put a wrapper around the sensors to protect them. Because you're doing that locally, you reduce the security envelope to a very, very small surface area. So it's easier to protect. You also create this kind of combinatorial security model where the dumb sensor plus the really sophisticated edge security results in a pretty sophisticated security approach. So again, security is number 4 on the list. And then number 5 was, in some cases, you have this need for autonomy, where there is a chance that the thing that's happening at the edge must be able to work if the internet goes down, if you're disconnected. And autonomous vehicles are great examples of that, mission critical environments, life safety systems. And so those kinds of things are better done at the edge because you reduce all the risk of being disconnected from the internet. And so it's those 5 kind of rules of thumb. They become the filter of what belongs at the edge. Turns out there's a ton of things that meet those 5 criteria. And that's why edges are starting to take off as a big piece of enterprise architecture.
That's wonderful. John, it's been such a pleasure. What a inspiring conversation. And, I learned a lot.
Yeah, Harpreet, thanks for having me. I mean, these are big topics for us, and they're important for everybody. So we appreciate the time today. This is a great conversation.